Hello, today is the first video in a series of videos on how to divide fractions. Today we're going to look at how do we model dividing with fractions without using the standard algorithm. I'm going to use some real-world examples that are very relevant to our time right now. The other day when I went to the grocery store, did my usual grocery shopping on a Sunday, I saw that all of the meat was sold out, all the smaller packages of meat. The only package of meat that was available for me to purchase to make dinner for my family for the week was one of those giant round tubes. It was like 10 pounds of meat. It was one whole tube. Okay? What I know is that my family, there's only 3 of us, we can't eat 10 pounds of meat in one sitting. So I thought, if I use 1/10 of this roll for each meal, how many meals could I get out of it? So that's what I'm looking at today. Is if I want to use 1/10 of the roll per meal, how many meals can I get out of this large hamburger roll I had to buy at Walmart? If I did write an algorithm, it would look like this. We're taking one whole, and we're dividing it into 1/10 pieces, and I want to know just how many pieces that would be. I'm not going to use the standard algorithm to solve that. I'm going to do it through modeling. 1/10 of one whole means that my whole can be split into 10 pieces. Fractional understanding of what 1/10 means, we started studying it back as early as 3rd grade. Okay, so I'm going to take my model, hamburger meat, I'm going to split it in half, because that's easier for me to split into 10 pieces. And then I'm going to split each side into 5 pieces. 1, 2, 3, 4, 5. Great. One, 2, 3, 4, 5. Awesome. I'm actually going to go ahead and just make my lines go through the writing. Now what I'm going to do to help me decide how many pieces are there is I'm going to go ahead and color it blue, but I'm going to alternate and have a blue 1/10, a white 1/10, a blue 1/10, a white 1/10. 1/10, 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, 10/10, one whole. So I've taken one whole, I've split it into 10 pieces. Okay? So, if I take this one whole roll and I split it into 1/10, I can get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 dinners out of one roll of meat. Now, how many pounds is each dinner going to how many pounds of hamburger is each dinner going to use? We don't know that unless we know exactly how much this massive roll of hamburger I bought from Walmart weighs. In this case, it was 10 pounds. Well, I can use 1/10 per dinner for 10 dinners, 1/10 of 10. Each dinner is going to be 1 pound. But that's an extra step that's not required for what I did with this problem. We can also model divisional fraction by using a number line. Okay? Give you another example. I like to try to get out and walk 5 miles every day, usually on a golf course. Every half mile, I like to stop and do push-ups. Summer's coming. I got to make sure that the old arms look good on the beach. Right? How many times in a 5-mile walk will I stop to do push-ups? That's what I'm looking for. Again, I got a number line. I've got an interval that's only 1 mile. You'll notice that I have to do a little extra work because I'm modeling this and I don't have half-mile markers on my number line. So I'm going to go in and I know a half mile is right between each hole. And now I got to figure how many times would I stop? Well, this just becomes using a number line to count, right? My standard algorithm would look like this. 5 miles divided by 1/2 will tell me how much. In a later video, we will move from modeling to just doing the math with the standard algorithm, which is one of the easiest concepts in using fractions, I promise. But for what we're doing today, now I use my number line to count. 1 half mile, 2 half miles, 3 half miles, 4, 5, 6, 7, 8, 9, 10. I end up stopping 10 times during my 5-mile walk to do push-ups. I'm sure between the two examples, you're already starting to notice a pattern. We're going to talk about that pattern later on. I also used easy numbers. I took one whole, divided it into 10 parts in the first example. Now I'm taking 5 and dividing it into halves. Let's use a little different numbers for the final model. And in this final model, you may want to stop and give it a shot yourself. We'll call it the Thanksgiving problem. My daughter makes the best apple pies. And every Thanksgiving or every Christmas, everybody wants one of my daughter's apple pies. But this past year, we only had enough apples to make 6 pies, but still everybody wanted one. So my daughter decided that she was going to split each pie into 1/3. She's going to take 6 pies and divide them into 1/3. Then we were going to try to figure out how many people we could still give pie to on Thanksgiving. So, Claire makes amazing pies. Everyone wants one. This year, she can only make 6 pies. If she is going to cut the pie into thirds and give 1/3 to each person, how many people can she give a pie to? Our standard algorithm, our equation that we're setting up, would be 6 divided into 1/3 segments equals how many segments? Pause the video, give it a shot yourself, and after you think you've come to an answer, you can hit play, and we'll see if your answer's right. I'm not going to pretend like you hit pause. How I would solve this problem is I would model it by drawing 6 pies. Pies usually come in circles, although it is more difficult to get accurate fractional representations if we do that, but for the modeling at this level, it'll work. I'm now going to draw that BMW symbol because we know thirds kind of looks like that. Now we have 6 pies at 3 pieces in each pie. I'm sure some of you have already got to the answer is 18. Okay? But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pieces of pie, 16, 17, 18. So if we take 6 pies and we divide it into 1/3, we can serve 18 people. Now, this seems a little different than what we're used to, because when we usually take a number and divide it by a number, our quotient ends up smaller. But not with fractions. When we take a whole number and we divide by a fraction, we're going to end up with a larger number than what we started with, because we're actually counting the number of smaller segments that we're creating. Kind of like when we were multiplying fractions by a fraction, we always got a smaller fraction. When we're taking a whole number and dividing it by a fraction, we're going to get a bigger number. The next video will be on how to do this with the standard algorithm.